Apologize everyone, due to some early circumstances on my end, my presentation has been rescheduled to now. My presentation may not be directly related to blockchain, but I have previously worked on blockchain-related project in the field of quality management. Specifically, it's quality defect traceability. In that work, I used the hyperlineage and the IPFS to combine to record the quality data. However, the study I'm presenting today is different. It aims to identify the root causes of the quality defects before they occur, which I refer to as the defect triggers. So let's begin. In the next 10 minutes, I will walk through the motivation for this work and the points of the department and the proposed architecture and its implementation. So now I will introduce the three research background of my research. First is quality management has been implemented as an essential component of the AECO project management. Quality issues remain prevalent in the construction practice. The main approach to quality management in the AECO industry is to control the major quality risk sources with a lack of research on the mechanism of the construction quality formation. The second research background is the BIM and the digital twins are developing rapidly, but there is a lack of the methods for processing multi-source heterogeneous quality data. And the third research background is the ontology and linked data technologies can be effectively utilized for the management of multi-source heterogeneous data. So based on the three research background, this study proposed 3 points of departure. The first is the evolution mechanism of the quality defect triggers. The second is the construction of quality linked data. The third is the process patterns for defect trigger identification. The study first redefined the 4 key quality concepts. The first is quality accidents, which refers to an unexpected event in which a product fails to meet the required standards of functionality and usage, resulting in economy loss, personal injury, or other forms of financial damage. The second is quality defects, which refers to a situation where the construction quality of a building project does not meet the mandatory standards for construction and the inspection items specified in the contract. The third is the quality concept, the defect trigger. The research posits that quality defects are triggered by object events, which the study defines as quality defect triggers. They manifest in non-competent material conditions, non-competent human behaviors, unfavorable construction environments, defective production processes, and manage these deficiencies and foster major factor. The last concept is quality deviation. Refers to the deviation value of product construction quality from the criteria value specified in the design blueprints. For example, the design length of longitude reinforcement of the concrete beam is 3,200 millimeter, and the process length is 3,205 millimeter. So the quality deviation is considered as 5 millimeter. So based on the 4 key concepts, the study researched the evolution mechanism of defect triggers. We found that defect triggers can be classified into deviation type and the non-deviation type. The deviation type is the quality deviation, and the non-deviation type is the quality is a management defect or some human-related reasons. So the formation of quality defect triggers ranges from 8 quality risks. And the study suggests the formation of quality defect trigger is latent in quality deviation and non-competent behaviors. So an analysis was conducted on the evolution mechanism from construction quality deviations and the non-competent behaviors to quality defect triggers, quality defects, and even quality accidents. Then the hierarchical of quality data and quality defect triggers are analyzed, the identification of defect trigger should be based on comparing project actual as-built data and with the standard criteria data. Therefore, construction of the quality standard layer and the quality data layer is essential for the quality defect trigger. To correctly perform quality defect trigger identification, it's necessary to delve into the fundamental construction process units. This requires analyze the project sub-deviation and sub-item construction works, construction processes, and subsequently establishing the defect trigger identification process patterns on the basis of the fundamental construction process elements, which is on the top of the hierarchy. Then use the protege. The construction quality ontology was initially developed to model semantic relationships among quality processes, quality defect trigger, and quality data and quality standards. Based on the ICDD conceptual framework, relationships between source quality data and the linked data, the as-built data and the criteria data were defined. Last, this study developed the process pattern for defect trigger identification based on the practical construction processes. Based on the sub-deviation, sub-item works, and the fundamental construction process of a project, this pattern identifies 3 key inspection points. First is the material acceptance. Second is the key construction processes, and the final acceptance. The key construction processes including on-site throwing, verification, cancelled works, and formation engineering, and etc. Quality defect trigger identity criteria is also be established, considering the required value, reference value, and the reference frequency. A quality deviation according the required exceeding the required value results in a quality defect. If the quality deviation exceeds the reference value, there is a high probability that it will evolve into a quality defect in subsequent process that's being identified as a defect trigger. Similarly, if the frequency of the quality deviation exceeds their reference frequency, there is also a high probability of it evolving into a quality defect. So based on the workflow of the defect trigger identification process pattern, the study developed the PSU code for defect trigger identification. The primary logic involves first the inspection key checkpoints such as the material acceptance until the inspection of entire sub-item construction work is finished. After completing the inspection of one sub-item construction work, the process then moves on to the next sub-item construction work until the entire deviation construction work is inspected. Then the study selected the case of reinforcement cageless non-completeness of cast-in-place piles construction to implementation. The construction process of the cast-in piles consists of 9 main steps, which with 5 key checkpoints. Using a protege instance data such as reinforcement cage length inspection data, data frequency, reinforcement cage criteria length, reinforcement length deviation criteria, and the deviation frequency were created within the construction quality ontology. Use the Sparkle plugin of the protege. Sparkle queries were written to successfully calculate the quality deviation and determine the defect trigger. So this study research on the evolution mechanism of quality defect trigger and proposed the architecture for defect trigger identification and use cast-in-place piles to implement the architecture. And we have 3 outlooks. The first is further theoretical research on the evolution mechanism of quality defect trigger should be conducted to determine more reliable quality deviation reference value and reference frequency for defect trigger identification. The second is automated process tools such as computer vision and the IFS convert should be introduced to achieve the automatic conversion of multi-source heterogeneous data into the structured RDF quality data instead of manual complying RDF files. The third is GraphDB, the graph database, should be introduced to enhance the scope and comparability of RDF data comparison. This effort will improve the efficiency of structuring multi-source heterogeneous data, quality deviation, quality deviation calculation, and quality defect trigger identification. That's all of my presentation. Thank you for your attention.